This video is on acid-base reactions. So first we have to know what an acid is. It's a substance that produces H plus ions when it dissolves in water. So another way to write this, I'm going to write or, is it could be an H3O plus, and that's what we call a hydronium ion. And I'll show you what I mean by this when I do an example equation. So when you have an acid, it will increase the H plus concentration in solution. So what I mean by that is it's going to produce H plus ions. So an example would be if I had HCl and it was aqueous, it would dissociate into your H plus ions and your Cl minus ions. So that would be increasing the H plus concentration. Now another way to write this would be, because HCl is aqueous, is you could write water as a reactant. And both of these reactions are showing the same thing. And the only difference is, as your H leaves the Cl from your hydrochloric acid, it goes with your water. So water can accept that H. And what you'll get is, you'll get the H with three H's with the O. So that's H3O plus, because you added a positive from your hydrogen and your chloride ion. So same thing, just a different way of writing it. So bases, for right now, are substances that produce OH minus when dissolved in water. So they increase the OH minus concentration in solution. So an example of this would be if we had NaOH, which is a strong base, aqueous, it would dissociate into Na plus and your hydroxide ion. Now something like a weak base, like NH3, which is a really common weak base, this ammonia, this is one you should know. When you react this with water, like we did up above, what happens here is one of the H's from the water leaves the water and goes with the NH3. So what you get in this case is you get NH4 plus and hydroxide. As the hydrogen leaves the water, you're left with hydroxide. All right, so when you get an acid that reacts with a base, something happens, and it kind of always happens the same way. So reacting a strong acid with a strong base produces a soluble salt and water. All right, so any acid, so strong or weak, can react with any base, strong or weak, to produce water and a salt. But if it's weak, it might not be soluble, meaning it might not dissolve in water. You might get an insoluble salt. All right, so quick thing, if you didn't know, we need to make sure we understand what a salt is. A salt doesn't mean it's NaCl, like table salt. Salt means an ionic compound. So anything positive, negative charge. So it doesn't have to be NaCl. So when you write these reactions, what you need to be aware of or pay attention to are your charges on your ions as you're making your new compounds. So let's do a few examples of these. All right, so if we react hydrochloric acid and sodium hydroxide, so I'm going to go through and label all my charges. All right, so this is essentially double replacement reaction, but we might get a soluble salt, not like our precipitate reactions. So something that's aqueous and water. Remember we said that's one of the ways these reactions, we know that they react. So hydrogen's going to go with hydroxide, so there's our water. Right, these two are going to combine, and these two are going to combine. That would be a liquid. And then sodium with chloride. So here our salt is actually salt. And if you look up chlorides on your solubility chart, you will see that they're aqueous, and Na is not one of its exceptions. So this is the balanced acid-base reaction. So let's do another one. Here we have phosphoric acid, or hydrogen phosphate. So we've got a +1 and a -3. And KOH is +1, -1. So here, let's see, hydrogen's going to go with hydroxide, right? There's our water. And K is going to go with phosphate. So I'm getting H2O. So there's my water. And my salt is going to be K3PO4. And this will be aqueous. You can look that up on your solubility chart. But then we need to balance this by putting a 3 in front of our water here, and a 3 in front of our KOH. So those are acid-base reactions.